Greetings, everyone. I'm Kari from Kanban, and I'm joined by Dmitry Karaivanov. We are both very excited to present to you today the major changes in the field of analytics and reporting in Kanban introduced with our latest product release 7.0. In the next hour, Dmitry will share with you how to make use of charts like the cycle time scatterplot, cycle time aging, flow efficiency, forecasting through Monte Carlo simulations. You'll also learn how to take advantage of the new Kanban integration with Power BI and bring your complex data to life with automated custom reports you can collaborate, publish, and share, standardize your reports across multiple Kanban boards, aggregate data from different systems into one report and display it on your Kanbanized dashboard. Now, allow me to pass the microphone on to Dimitar.
Thank you, Kari, and hello, everybody. I'm very happy to see so many people joining in this webinar. I'm delighted to present to you the new changes we have implemented into the product, especially the part around analytics, reporting, and metrics, which is the focus of this webinar. As Kari said, please post your questions at the end of the session. I will try to answer as many of them as possible. Right now, I'm going to share my screen. I have a few slides I want to go through just so we set the scene for the demos after that. The first question I'd like to touch today is why bother? Why should you bother with these things that we're going to talk about anyway? The fact that you're here at this webinar speaks for itself, that you realize that we need to measure stuff, we need to be able to forecast our projects and ultimately have a better idea of how things work. But there are three specific things why I believe flow metrics in general are very important. The first thing is that flow metrics, to me at least, are the most realistic way to see how work gets done in my company, in customers' companies in general. The people who are familiar with project management or agile management, we know how we tend to abstract the work in terms of metrics. We tend to use story points, we tend to use t-shirt sizes or Fibonacci numbers or whatever. And I do believe that the simplest we go with metrics in terms of how we measure stuff, the better. So that's why flow metrics are so natural to me. We measure time, elapsed time, cycle time, lead time, however you want to call it. We measure a number of work items completed. It's very specific. It's super close to reality. And I think that's fundamental from here on. The second thing is that if we ultimately want to do a good job, we need to be able to measure and manage risk. How do we get taught in school and in management schools how to measure and manage risk? We fill in a form with the likelihood of a risk happening, with the impact of the risk in case it happens, and then we're done. I think that's not a good way to manage risks. I think a good way to manage risk is to actually have a very good idea what you can expect from your workflows, from your teams, from your organization in general. I think that's the only reasonable way to manage risk, to be proactive about it and do all the right things in the best possible way so that you don't get into the impact scenario we talked about. And I think that's how we can use those three simple metrics: cycle time, work in progress, and throughput, the core metrics in Kanban, to set the scene, to lay the foundation of a predictable workflow that we can just take a look at, analyze, get a very good expectation what we can achieve, and then manage all the risks proactively, as we just said. So it's not about knowing who does what, and I'm talking from my experience. It's not about who is your best employee. It's not about how much time I spend on working on problems. It's about how I get a predictable organization, how I get a predictable workflow for all my teams. That's what we're after here. All right. And how do we get there? I'm going to talk about two sets of things. The first set is these analytics. I'm sure some of you will recognize what we're showing here. It's what used to be the premium analytics in Kanbanize. They have been around for quite some time now, but only the people who got the premium analytics package were able to access that. We saw that the premium analytics worked so much better than our core analytics that we used to have. So we decided to basically promote the premium to be the default analytics in Kanbanize. Maybe you know these things already, maybe you don't. I'm sure it's going to be new for at least half of the people on the webinar. So I will definitely recommend that you bear with me while I go through the most important charts here. And then the second piece I want to talk about is the Power BI integration. It's a whole new universe of reporting that we just enabled with the integration between Kanbanize and BI. And I'd like to show you some real world examples that we already have with some of our customers. I'm happy to see some of them on this webinar actually. So definitely we put the theory next to the practice and we combine those things. All right, without further ado, let me switch to my browser. And I actually start with showing you the analytics that are now the default ones. What we see here is one of the most useful charts in the Kanbanize analytics set. We call it the cycle time scatter plot. The cycle time scatter plot visualizes the work items that have been completed on a given board inside a given workflow. Later on, I will show you how you can combine this and visualize data across multiple boards, something which is new for everybody. So even if you have seen these charts before, now you can use them across multiple boards. We'll touch that a bit later. Right now, I'm showing you data from one board, from one workflow. The new thing for everybody is that you can control which data you can see on those charts from here. So you can add multiple workflows. In the past, it used to be just one workflow, and now we allowed multiple workflows, which is quite useful. And then you can apply other filters. For example, you may want to see only the cards with high priority or whatever. All right, back to the chart. This chart shows you the cycle time of all the cards that have been completed inside this workflow for the specified period right here. On the x-axis, we have a timeline. On the y-axis, we have cycle time. So if something was finished on the 1st of April 2019, we will plot it on this vertical, and where it goes exactly depends on the cycle time. If something is finished on the 1st of April and it has a cycle time of 25 days, we will plot it right here. I hope that's clear. And besides showing you some visual representation of how work actually happens inside the board, this chart is important for one other reason. And the reason is those percentiles right here. We have 50th percentile, 70th percentile, the 85th percentile, and the 95th percentile. If you go all the way to the left, following the horizontal lines, you will see a number for each of those lines, 8, 5, 2, 1. This basically means that this workflow that we're visualizing here is capable of finishing 95% of the work within 8 days or less. It's capable of finishing 85% of the work within 5 days or less, 70% of the work within 2 days or less, and so on and so forth. And if you're wondering why is this useful, here's why. Imagine you get a new request coming into this workflow, and you naturally ask the question, hey, how much time do I need to get this done? Then you can instantly say there is 95% probability that I will complete this work item within 8 days, as long as it's something like what we used to do here. If it's not something completely radically new, and I have no idea what it is, then 8 days will be more than certain to be sufficient. So this chart allows you to forecast work on an individual work item level. Obviously, the less dispersed the dots on this chart are, the better. So things like that, what's that, 32 days, it's obviously an outlier. So the fewer outliers you have, the better. But this picture, what I'm showing you here, is actually a good picture. Most pictures would look much more dispersed. And the 95th percentile would probably be way above the 8 days. Of course, this depends on the workflow, it depends on the work type, and so on and so forth. But the idea is that you should keep those dots as close to the x-axis as possible, because that's how you're pretty fast to complete work. One thing to pay attention to while looking at this chart is whether those dots tend to grow on the right. So if we do something like this, if the dots grow to the right, if there's this upwards trend, it means that your cycle time is actually going up. It means you are getting slower over time. What we see here, just visually taking a look at it, is somewhat this, which is stable cycle time, actually a little bit going down, which is good. So we just take a look at this chart and we know this workflow is somewhat stable. I say somewhat because that's not a necessary condition to have a stable workflow. We'll talk about that later. I want to show you something else on this chart. You can mark the cards that have been blocked. So you can toggle on and off which cards have been blocked, which again gives you a pretty good idea how frequently cards get blocked. It's not that frequent on this workflow. Other workflows could have almost all the cards being blocked at some point in time. So it's a good visual indicator. All right. If you have any questions about this chart, put them on a Q&A session. I will now move on to the next one, which is again about cycle time. This time it's about a histogram. Actually, the histogram is somewhat the same chart as a scatter plot, but it just visualizes the data differently. It aggregates the data. And what this chart shows you is that you have a lot of items, like 50% of the items on this workflow were completed within 1 day. And then we have 173 work items were completed within 2 days. This gives you the distribution of cycle time in this workflow. Obviously, this here on the right, we call it a tail. Obviously, the longer the tail is, the worse, because it means that a work item can be done anywhere between 1 and 32 days. And if you're doing something that's supposed to be finished in 10 days and you happen to finish in 30 days, you're not very excited about it. So a good thing here on this chart is to try to shorten this tail on the right. Ideally, you would only have work items here within your SLA. If your SLA service level agreement is around 8 days or 10 days, the ideal is to only have something here. You will always have a tail that's just live, but just try to analyze this, take a look at it, and try to make it shorter. All right, so the last one of the cycle time family, the heat map, it's one of my favorite charts actually. It shows you where the most time gets accumulated according to the workflow. So on the x-axis is the actual workflow of the board that we're looking. And then on the y-axis, you can choose different topics. So right here, we've chosen the type. So according to the type, well, the cards with no type would take the most time here. If you want to filter that and just ignore the none type, you could go here to item filter. You can find the type. You can select all and just remove the none here. And then we see that the slowest part of the workflow is this experiment thing in those two areas. It's a good way to visualize bottlenecks. It might not actually be a bottleneck, this column here, but it's a signal to check whether something there could be improved. Because if we improve this, then the overall flow through this workflow is likely to be improved. All right, let's quickly go through the throughput run chart. This chart shows you day over day. Again, we have a timeline on the axis, how much work you're able to deliver every day. This is a timeline on the x-axis, and on the y-axis we have actual number of work items. Could that be tasks? That could be projects. This could be anything that you measure on this workflow. Whatever runs through the workflow, that's what is visualized here. What we see on this chart, how we read this chart. Well, first of all, we don't want to see very often lows and peaks and lows and peaks. We would rather see something stable, something like that. I think that's a rather stable chart for the throughput run chart, because this means that we're able to consistently deliver projects, work, whatever, to the customer of this workflow. It might be an end customer if this is a support queue, let's say, or it could be an internal customer if you are a shared service team inside an organization. What we see here is Christmas. So Christmas means no throughput. That's, at least in Europe, it's like that. I think that's the previous Christmas. So whenever you see something blank in our boards, it means Christmas. But apart from that, we tend to be very stable with this workflow. This is what you want to see. If you see a lot of work here, some days having very high throughput, some days having very low throughput, it either means that you're batching your work, so you're collecting a big batch of work and you're delivering it at once, which is somewhat okay if it works for you, although that's the opposite of being risk averse. So if you batch work, you could see those highs and lows, but if you're streamlining your work, constant flow of work, then you should be seeing something stable here. All right, let me go to WIP. WIP, it has a very, very nice chart, the aging work in progress. This is exactly the same thing as a scatter plot that we looked before, but this time we are seeing the work items which are currently being worked on. Not finished, but right now in the system. And the important thing about this chart is the pace percentile. Again, you have those percentiles you can enable from the 50th to the 95th. We typically use the 85th or the 95th percentile because we tend to be not that optimistic in our planning. We tend to be on the safe side. If you want to be on the safe side, you use the 95th percentile or the 85th percentile. So if you enable the 95th percentile here, what does it mean? Well, it means that this dark orange/brown area, this is a map of your historical work when, at what point in time, the work items were going out of the corresponding stage. Those stages, these are the columns in your workflow. So you have in progress, ready for review, peer review, waiting on link, whatever. This orange area will map when historical cards were getting out. At what point in time? We have age here. Another way to say it is how old the items were historically when they used to leave the corresponding stages. So if we're seeing these work items inside this area, the brown area, this means that we are not slower compared to our historical data. If we were to see them here in the red area, then it would mean that our 95th percentile is growing in terms of days. So instead of having our 95th percentile for the in-progress area to be the 6th day, it might actually be changing to be the 8th day a few weeks from now. So having work items in the red area is a signal that our age, our cycle time might be growing over time. We just don't know yet, because if we look at the scatter plot, we're seeing what happened, which might not have happened yet, and the aging work is what is currently happening. If you want to change that, you can go to the 85th percentile. As you see, the 85th percentile is lower right here. So we have 40 in progress area. Our 85th percentile is on the 4th day. Again, those two work items are here, which is great. If they were above the yellow area, then we would say, hey, our 85th percentile is growing in terms of days. What can we do about it to not allow it to grow? Because we don't want it to grow. We want this to be either stable or decreasing. We want to be faster. We don't want to be slower. And it's a very good chart to inspect every day. If you are at a team meeting, or every week if you are at a department meeting, depending on whether you work on tasks or projects, it's always useful to take a look at this chart. And if something is in the red area, just pay attention to it. Make it flow faster. All right. Then the run chart for the work in progress is something like the throughput run chart, but this time it's how much work in progress I'm having over time in my queues, in my workflows. So in Kanban, we know that it's good to limit work in progress. And this chart here visualizes whether we are accumulating more WIP over time or not. What we see here is that actually the WIP is going a bit down. We have a trend here, so we can enable the trend. And as you see, the trend line somewhat goes down, which might be good, might not be good. It could be good if we see the same throughput from our system. If we see the same throughput, lower work in progress means lower cycle times, which means we're getting faster. But it could just mean people are not pulling any work and they're somewhere on vacation. So we can't tell just looking at this chart, but it's part of our analysis. All right, so how do we know if we are actually delivering work? The next chart is a very good indicator to show you that. It's cumulative flow diagram. It's one of the most popular charts in the Kanban world, if not the most popular. The cumulative flow diagram, it shows you the accumulation of work over time. So it's never growing, it's never going down, it's always accumulating over time. As you can see, we have somewhat 800 work items delivered by this workflow since June 2018. It's never going down. Again, on the x-axis, we have a timeline. On the y-axis, we have number of work items. This chart is useful for several reasons. First of all, you can see how the arrivals in the process and the departures in the process compare. If I zoom in a little, because we can't really see very well this chart, let me hide this. The very top line on this chart, the very top, whichever this one is, the brown area, it maps when new work gets into the system. Somebody asks you to do something on the 25th of February, we'll put a dot here. Somebody asks to do more work on the 4th of March, we would increase that because more work has been requested. And when something is out of the system, when you actually complete it, then we will map it on the blue area here. This blue area, the big blue area, it's how much work we have finished actually. So that's why the difference between the very top and the very bottom is how much work in progress we have actually. How much has been requested minus the done gives us work in progress. And if you see the cursor here, it shows you 6 work items were here in progress. We had 3, and those guys change over time. So it's a very good way to visually see how work in progress has been changing over time. The horizontal line, and let me zoom in again to make it visualize better. The horizontal line is the difference between when work items have been completed and when work items have been requested. I want to point out that it might not be the very same work items. So some were requested, others were completed. These could be the same, these could be different. You never know. This chart doesn't show you that. But you know that on average, you needed 2 days to get stuff done. This is your approximate average cycle time here. And if you scroll through this chart, you can see how your approximate average cycle time changes. So it varies between 0, 1, 2, 3, 4 days, 5 days. You can inspect that. And because this chart is so good, and I'm not trying to brag too much about it, but this chart is so good that you don't see anything besides the blue area going up. But if you are increasing your work in progress, if you are letting more items in than work items have been completed, then the top and the bottom would diverge. So if I again scratch something here, if your arrivals are like this, so the chart goes like this, and then your departures, meaning how much work you get done, is like this, it would be fairly visible on this chart. And if you take a look and you see a picture like this, then you instantly know that you are getting slower. How do you know that? Well, we already talked about this horizontal line here. It was the approximate average cycle time. So right here, the approximate average cycle time was, I don't know, 10, 12 days or something. Here, the approximate average cycle time is now almost a month. It's a month and a half here. It's 2 months here, 3 months here. And as you see, it's always growing. If you allow more work to get in than work gets out, then you're getting slower just because of, and that visualization shows it, proves it. So that's why we actually use work in progress limits in Kanban. If you have a team that has limited the work in progress, then you see a chart like this. The WIP never grows, cycle time is stable, it just works perfectly well. If you don't apply any WIP limits, and if there's a push behavior, which means that we enter new work into the system without necessarily having something out of the system, it might happen to be like this. And then cycle time just goes out of control. One other thing that you can see on this chart is throughput. And throughput is basically slope. So this slope, this slope, this slope, this is the throughput. The steeper it is, the greater the throughput, because this is a work items here. So the more work items we get for a time unit, like a day, a month, or something, the greater the throughput is. So by taking a look at this chart, I can instantly tell you where Christmas was without even taking a look at the timeline. We obviously had no throughput here. It was just a plain line at 600 something. Basically, the company had stopped. It's the same here. So when you see this plateaus, it means no throughput, something's going on. If it's not something you can explain with Christmas or whatever, it's a good idea that you take a look. And those changes here, they're also visible. So something happened here. It wasn't Christmas because it's April, but something happened. As you see, we were going up, then plateau, then again up, it was good, it was good, it was good, it was good. Christmas, now we are faster, then something happened here, and now we're again faster. So I don't know what it is, but if I find it odd, I can take a look at this chart and instantly realize there are changes in the throughput of my system. So it's a very, very, very useful chart, one of the best. I want to switch to flow efficiency now. Flow efficiency is a chart that shows you this number here. It shows you what percentage of the time you were actually working on the work items versus how much time the work items were waiting for somebody to take something, to take them and do something about it. How do you know if a work item is waiting? Well, there are columns on the Kanban board which we have implemented, and we know they are queues. How do you know if a work column is a queue? Well, it typically says something like waiting on or ready for or something like this. So it's a good idea to have those columns on your board because we accumulate the time, and then we can tell you 67.7% of the time you're actually doing something, and then 32.3% of the time the work just sits there waiting. And this is a huge number. We have been doing Kanban for 10 years. Everybody at Kanbanize is brainwashed on Kanban and flow metrics, and then we are 67.7%. If you get to a company or a team that is just starting with Kanban or lean management in general, you would see something like 5%, 10%. 20% is way above average. And if you think about it, it means that 90% of the time or 80% of the time, work just sits there waiting. And if we were to pay attention to that and limit the work in progress in those queue columns, the ready for, the waiting on columns, if we were to limit work in progress in those columns and force the system to work on them, to act on them, and resolve them in the fastest way possible, we could achieve a 500% improvement in cycle time without adding a single person to the team. It's just optimizing our current workflow to be much, much faster. Well, this comes with a caveat, because if you improve for cycle time, it might actually result in a lower throughput. So if you want to be 100% flow efficient, this would mean when a work item is waiting on somebody to pay attention to it, this somebody has to stop immediately what they're doing and pay attention to the work that's waiting, which is good for the flow efficiency of this waiting item, but it's bad because it leads to a context switch for this person, and then it will ultimately harm your overall process. So we can't say that flow efficiency going up is always good. It's likely a good thing, but it really matters how you achieve it. So my advice for you is to take a look at this chart at least once a month. And if you see a number that's below 20, that's below 30, you have a lot of room for improvement. And that would not be at the cost of throughput. That's my guess. Of course, I can't promise you that because I don't know what you guys do and what work items we have. But if you have flow efficiency below 20%, there's a very good chance that you can improve that without harming your throughput. All right. Now we're getting to the last two things I want to show you. It's the dessert of the analytics, the forecasting charts. Those are two Monte Carlo simulations. How many and when? A Monte Carlo simulation is a simulation that will run a lot of trials based on your historical data. Let me actually open one. It will run a lot of trials based on your historical throughput, which is this here. So this is a throughput run chart, if you remember. So we will run 10,000 trials by default. You can run more. up to 1 million. And this simulation will randomly click on points here based on your historical throughput, and it will create this distribution below. So we will be able to tell you with a probability like this, like 85% probability, 95% probability, how much work in terms of work items you will be able to finish by certain date. Imagine you have a deadline on the 4th of November. I'm just making this up. The simulation will rerun itself and it will show you, hey, there is 85% probability that by the 4th of November, you will finish 191 work items. If you want to be more certain, go for 180. So if you're asked how much work can we get done by the deadline, that's your answer. And this is the place where people usually tell us, hey, but you never know that because the work items are different in size, because the work items might be too complex. And yes, that's true. That's why it's so important for us to keep our cycle times smaller. That's why it's so important to keep this tail here shorter. If you remember, I was telling you, try to keep this tail shorter. Try to finish work always within some certain period of time. This is right sizing. So if something is very big, well, break it down into chunks of work and then flow it through the system for 8 days or less. If you do this consistently over and over and over and over again, like here, then those forecasts will be much more accurate compared to one item taking 1 day and one item taking 3 months. But if you achieve this stability of your process, then those forecasts, as you see, are a piece of cake. And you were able to forecast 180 work items within 1 second. How much time would it take for you to forecast that if you had to drill down, see the details, ask the team for estimations, do a story mapping or whatever? It would take you days, if not weeks. This forecast, the more accurate the data, the more accurate the forecast. Of course, garbage in, garbage out. You should know that. So how do we know if it's garbage in, garbage out? Well, if your cycle time tails on the histogram are not long, if you're not allowing your work to age too much, which is this here, the aging, if we don't see work items here in the red area, if our cumulative flow diagram does not diverge the trend lines, you can visualize the rate lines here. These lines are actually 2 here, but because this team is keeping strict work in progress limits, you can't even tell. But maybe if I zoom in, and you will be able to see that those are actually 2 lines here. If those 2 lines are not diverging from one another, then your overall system is stable. And if it is stable, then these forecasts will work. So this is not a magic wand, all right? It's not something you can just run and it gives you the right answer. If you do the groundwork, then it will give you the right answer. And just so I make sure I show you the last simulation, it's the other way around. Imagine you have a backlog of, I don't know, 284 work items. If you enter that backlog here, then the simulation can give you an approximate end date. It will tell you there's a good chance, 85%, that you will finish by the 25th of January 2021. And then you know what to do with that information. I didn't stress that enough, but it's absolutely critical that we always assign a probability to our estimations or our deadlines. If you communicate the 25th of January 2021 without this probability here, then you've just committed to a fixed date delivery, and in knowledge work, that's rarely realistic. So my advice and the advice of the people that I quote, actually, those are Donald Reinertsen, Daniel Vacanti. Those people, they always tell us assign a probability to your estimations. All right, because we have just 20 minutes left and I still want to have at least 5 minutes for questions, I need to speed up a little and show you a few other things. Remember when I told you that you can show the charts across multiple boards? Yes, that's how we do it. With widgets on the dashboard inside Kanbanize, you can come here, select Add Widget, then scroll down a bit, and all these charts are available as widgets. And when you choose one, we will ask you to select any workflow from any board. You can use this workflow from that board and add a second workflow from some other board. And then you can list as many of them as you want. You add that to the dashboard, and then it starts working like this. You can forecast across multiple boards. You can visualize cycle time across multiple boards. You have a CFD across multiple boards. So it's really, really cool stuff. I've been wanting this for ages. I need to tell you, I've been wanting this for 5 years now. And it's finally there, which is a very, very exciting moment for me. All right, I will pause here with the charts, and I will go to the next section of this webinar, which is about our Power BI integration. So how does it work? First of all, the Power BI integration works. Let me back up. What is Power BI? All right. What is Power BI? Power BI is Microsoft's business intelligence tool. It looks like this. This is the desktop application. So it has a desktop application. It also has a cloud service. So you can create dashboards, custom dashboards with any data from a database, from a service, from Excel, from any data source that you can imagine. You can create dashboards with it. The way our integration works is we create the dashboards inside the desktop application, and then we publish those to the service from where you can embed them into Kanbanize. I just got a note from Carrie that we have 13 questions, so I will probably have to leave at least 10 minutes for questions, so I will speed this up. Here's how it works. To be able to get the data into BI, you go to Kanbanize, and you create a search query from the search. I hope you all know how to work with the search. You configure some criteria, you click search, you get the data. Then you go to the save filter, and when you save it, there's a checkbox you can select against the Power BI query. When you do so, there's this string that we generate for you. You copy it, then you go to Power BI, you go to get data. Okay, it takes a while to load. Then you go to blank query right here. You connect that. A new window opens. You go to advanced editor, and you just paste what you copied from Kanbanize. It's as simple as that. So when you do so, I will discard this because I want to save some time, but come on. When you do so, it looks like this. Just one moment for it to load. It looks like this. It's just a table with information. This table with information is exactly the same thing as the one here. So whatever you search for, that's what you get into the query editor. From then on, you save the changes, and you can start building your dashboards inside Power BI. For example, we have a chart here, a pie chart here, that works on the basis of priority. So we have visualized how the priorities from this data set compare in terms of percentage. What you can do is you can visualize the cycle time of all the cards. You can have a matrix with all the work items and their cycle time, block time, priority, basically anything that you can think of. And that's why it's so powerful. I don't want to waste time building the reports right away. That's why I will show you how they actually look like. If you publish the report to the service, the online service of Microsoft, it's part of the Office 365 platform. You can take it and you can embed it back into Kanbanize. You just go here, you go to Add Widget, then you choose the Power BI report widget, you paste the URL that you get from the Power BI online service, and then it looks like this. So a few examples. What we have here. We have here a marketing board, a business development board with all the initiatives. And by the way, this is real data with all the initiatives that have been finished. This light blue line shows you how many initiatives have been finished per month and with what average cycle time. This is something I prepared for myself. It's the same here. How many initiatives, what's the average cycle time? You can show that for multiple teams. You can aggregate data for multiple boards, multiple teams, multiple workflows. Here below, it's a table representation that you can browse, see which initiatives exactly contributed to those numbers. Actually, if you click here, it will filter the table below to show you exactly which initiatives were accounted for here. Another example. You will rarely hear me talk about Gantt charts, but actually you can create one on the level of initiatives of a timeline. So we have these timeline fields in Kanbanize. If you use start dates and end dates for your initiatives, you can visualize them here along with some milestones and things like that. And by the way, there are multiple ways to visualize them. So it's very, very flexible thing. This is custom visualizations that I've imported into my Power BI desktop application. Right here, we have a capacity allocation dashboard, and the lady that we created it with is actually on this webinar. So it's sample data, of course, but this is how you can allocate capacity in the future. So right here, we have created initiatives per product, and then we have estimations that are derived from within Kanbanize, how much time we actually gonna spend on the current month with external people and internal people, and then in the next month, and then in the next month, and then in the next month, and we have an overall estimation of the effort per product. So it's like this. You have the total number of estimated man days per month per product. And these measures, they're all calculated inside Power BI with data that comes directly from Kanbanize. So if you go change something in Kanbanize, this dashboard will change automatically. Another example that we have, it's for the software development people. Again, a real customer scenario. One of our customers wanted to have this sort of visualization, which is how many bugs and how many user stories I get every month, and how do they compare. So these light blue ones, these are the bugs. The dark blue ones, these are features or news stories or projects, whatever you want to call them. And then the orange line is the ratio between how many bugs and how per story we have. So how many bugs per feature. Obviously, the more, the worse, and the lower, the better. Then we have the average cycle time for bugs and the average cycle time for stories. And again, you can filter the table here. And I can go on forever. You know, really, I can go on forever. There are unlimited options for you to create reports with Power BI. And I encourage you to take a look at this integration because it's very powerful. All right, I will now go ahead and point myself to the questions we've got because I know we have a lot of them. Hopefully, I will be able to address as many of them as I can. All right. Let's take the first question. As I understand, in flow metrics, they are important from day one of a project. but the new implementation of flow metrics in Kanbanize does only work with 10 plus finished work items, so we don't see any until very late. Will the finished flow metrics feature be usable from day one? That's a very good question. And the answer is that you need at least 10 to 30 work items to be able to reliably forecast anything inside a workflow. And actually, the way we have implemented the workspaces in Kanbanize is exactly because of this. So let me back up and let me clarify. If you create a new project in Kanbanize, our idea would be that you use a management workspace to plan the project. But this management workspace connects to team boards that are already a stable structure because the teams have presumably used them for some time now. So even though it's a new project, the teams working on the project already have historical data. We don't advise people to create new team boards for new projects, only new management boards for new projects, but still have the team board stable. That's a fundamental thing because that's how we make sure we have enough data to feed into the project view and actually do some reliable forecast there. I hope this makes sense, but if you are using Kanbanize for 1 month, then any new project should be okay. All right, next question. How can I use such data from analytics as it was created versus done in previous? I would advise you to take a look at Power BI because that's a report you can easily create in Power BI. If you want to get help on that, please let our support team know. We'll be there for you. We don't plan to recreate the created versus done chart, but it's going to be very easy to do it in Power BI. If you're not using Power BI, then you should know we are planning such integrations with Tableau and Google Data Studio in the future. So basically, any of the popular BI solutions there will get it covered. Okay, next question. What is the minimum size of the project or team for this data to create correct estimation? We have a team of 4 people delivering a few tasks a week. Would this still give us a valuable information? The answer is yes, because we base the forecasts on your historical throughput. So if you have a smaller team that delivers fewer work items, this is already embedded into the data set that we base the forecast on. So if you have lower throughput, we will project lower throughput in the future. If you have higher throughput, we will project higher throughput in the future. The size of the team does not matter. The number of work items delivered matters to the extent that it's not a good thing to have many days with zero throughput. If you have many days with zero throughput, then the forecast will not be that reliable because we will be hitting 0, 0, 0, 0, and then there's no guarantee that we'll project reliably in the future. So if the work items are big, I would suggest maybe break them down a little so that you can deliver something at least every other day. That's when the estimation is going to be more reliable. Okay, so we have a question. Can the cycle time scatter plot show the vertical axis on a logarithmic scale? No, unfortunately, that's not possible, but it's a good question, and I'll take note about it to address that with R&D in a future release. So thanks for that, Robert. Another question, can I delete one task in the cycle time histogram diagram? Actually, that's a very good question because it's something I forgot to mention. If you delete tasks from your process, for example, a task goes in and then you decide to cancel that work and you just delete it, this will be a violation of the definition of stability of a system. A system is stable when work that gets into it gets out of it. If it just disappears, then the metrics will be shuffled and the forecasts will not be reliable. So I just wanted to mention that. So please don't delete work. If you want to cancel something, put a tag canceled and then move it to done. So what about deleting a work item from from the chart? No, you cannot delete a work item from the chart. You can probably filter somehow if you don't want to see it. You can't filter by cycle time, but if you put some tag like outlier, for example, and then you remove this tag from the data set, then you're going to have it. Okay. Next question is, my aging work in progress chart does not show any colors. Do I have to enable them somewhere? Yeah, the aging whip will show colors if you select one of the paste percentiles. So if you select those, it will be showing up the colors. Maybe those are not selected. Okay, so next question is, on the whip run chart, what is the algorithm for calculating the trend line? Is it the running average? Can a different algorithm be chosen? Yes, it's a running average, and I would be open to talk to you, Robert, if you want to, about other algorithms that you have in mind, because that's the one we're using. But again, we're open for feedback on that. So please have a follow-up with us. I'd love to talk. Next question, is there a way to exclude weekends in CFD or other charts? This is something we want to do in the future. It's not there yet. Specifically for the CFD, I would say maybe it doesn't make too much sense. Well, I don't know. It depends. Maybe it does for your scenario, but for the scatter plot, for example, or for the aging, I would say it's something useful. When I talk about analytics, I often quote Daniel Vacanti. I think he's one of the best people to quote on metrics. He's not a believer in this particular approach because what he says is that the customer doesn't care whether you work on the weekend or not. The customer cares that you do the work within a certain time. And it's not typically working days. It's just 2 months. 1 month, 3 months. If you say I'm going to do this in 3 months, nobody hears 3 working months. They hear 3 months in general. So I myself would say it's a good enhancement. That's what Daniel Vacanti says. Chances are that we will improve this in the future. Okay, another question. Do these analytics tools include archived results? Yes. Yes, the answer is yes. Okay. Another question, can you do Monte Carlo bar by cart type? Yes. If you open a chart, let's say like this, and then you go to the item filter right here, then you can find the type and, for example, select only one type. If you do so, the forecast will be rerun with only this data type in mind. So yes, the answer is yes. I have a few more questions. We're at the top of the hour. So if you guys are able to stay, I will just address the rest of the questions. If not, thank you a lot for attending. But I just want to answer those questions. Okay, another one about forecasting. My team works at 3 projects at the same time. How can I say project 1 will be finished in 20 days with a certainty of 85% within the Monte Carlo simulation? I would say that you need to have a way to tag those cards. And this is easy with the synchronization option in Kanbanize. So whenever you create a child card, take some tag from the parent. And then when you run the forecast, do it on the team level, filter by tag, and then you will see those cards specifically when they can be finished. Okay, next question. Time in which an item is blocked could be a waiting time. Is the duration of the blockers taken into account into the flow efficiency? Yes, it's taken into account, and the block time is calculated as non-efficient time. So the bigger the block time is, the lower your flow efficiency will be. Okay, the Power BI integration looks like a game changer for me. Great work. Thank you so much, Kev. When is this going to be available to us? As I don't currently see the option for it in the saving a filter. If that's the case, then you probably are one of the customers that runs on a dedicated cloud instance. We update those with 1 month delay after the shared instances. So this means in 2 weeks from now, at latest, you should have that. Okay, which data, for example, is used to create capacity planning chart with scene? We use the planned start date and the planned end date of the initiatives. Then we divide those by the size of the initiative or by a custom field representing the effort. And then we distribute this time across the entire duration of the initiative. So to answer the question directly, it's just a start date, an end date, and an estimated size of the initiative. I would be happy to follow up on that. And Rico, if you want to just drop us an email, we would discuss that in detail. And then the last question: when using the search query data to create a Power BI report, can this data be real time? Yes, it's actually a real time thing. Well, close to real time. It depends on how frequently BI will refresh the data. If by default you have one refresh per day, then the data will be 1 day old. But the thing is that BI will always take information from Kanbanize, which is the current state of the data. It's not a snapshot in the past. It's always live data. Okay. I'm sorry I exceeded the time with 2 minutes, but I just wanted to address all questions. Thank you very much for attending. Me and Carrie, we are open to continue the conversation with any of you who is interested to learn more about analytics or basically any other topic. So please feel free to reach out to us. And thank you so much for attending. Have a great day.